Hi everyone, it's Coach Fred and I'm going over question number 29 in the Writing Equations of Lines packet. Someone asked about it. And it says a pop music festival sells tickets. After 2 hours, they've sold 600 tickets. And after 5 hours, they've sold 1,500 tickets. Write a linear function to model this situation. So that's part one. And then use your model to find the number of hours it took the festival to sell 6,000 tickets. All right, so the fact is they're telling us they need us to write a linear function. So that typically means that we're going to be looking for a function to write a function in y equals mx plus b form, though that doesn't need to be the form that you use to write the function. But that's usually what we want our final answer to look like to get the linear function, okay? All right, so in order to do that, I do need some points, okay? And so what I would do is I have to identify what is my x and what is my y for the linear function. So I always ask myself when I'm trying to determine what's x and y, what depends on what? Did the hours depend on the tickets, or did the tickets sold depend on the hours? And so the tickets sold depends on the hours, and what's important there is that y always depends on x. So y depends on x. If you watched any of my other videos, you might have heard me say that, okay? So ask yourself the question, what depends on what? Because y always depends on x. All right, so we have to get our variables. So in this case, we said that hours was our x. So x would be number of hours. And y would be number of tickets sold. Okay, so now to write a linear equation of any kind, the minimum you need to write that equation would be a point and a slope. That's the minimum. But we've got some data here that we can turn into points. So, for example, after 2 hours, you sold 600 tickets, so that would be 2,600. And after 5 hours, they've sold 1,500 tickets. All right, so I have 2 points. Again, the minimum you need to write an equation of a line is a point and a slope. So now I'm going to calculate the slope, okay, or the rate of change, because it's a word problem. So remember, when we do that, our rate of change would be y2 minus y1 over x2 minus x1. And here we've got x1, y1, x2, y2. So I'm going to plug those right in. So I'm going to do 1,500 minus 600 all over 5 minus 2. Okay, so 1,500 minus 600 is 900. 900 over 3 gives me 300. So that means for every hour, that's what this means. Think of it as 300 over 1. That means for every 1 hour, I'm selling 300 tickets. Okay, so now we have to write our model. So we have a point and we have a slope, because remember, rate of change is just another name for slope. So I tend to use, if I have a point and a slope, I tend to use point slope to write my initial equation. All right, so how would I do that? I would use the formula y minus y1 equals m times x minus x1. And I would plug in my point. I have my x1, y1, and I have my slope. So that's going to be y minus 600 equals 300 times x minus 2. Now remember, I said when it says linear function, we really should put it into y equals mx plus b, so I'm going to do that. I'm going to distribute, but it really depends on the teacher preference. So y minus 600 equals 300x minus 600. So I'm going to add 600 to both sides. And so my equation is y equals 300x. Okay, so there's my model, y equals 300x. That will model, and that will tell us, given the number of hours, we'll always be able to find the number of tickets. All right, so that's part one of the question. Part two says, and I'll come over here, use your model to find the number of hours it took to sell 6,000 tickets. So they're giving me my y, they're asking me for my x, so I'm going to substitute 6,000 in for y into the equation. And then I'm just going to solve the equation. So I'm going to divide both sides by 300. Remember, trick on division here is like I've got 0, so I can cancel 2 zeros. So I have 60 divided by 3, which is 20. So it would take about, so I'd write the answer, it would take 20 hours to sell 6,000 tickets. All right. Hopefully that was a helpful video. Have a great day.